I would love to give you time for your homework. Absolutely would love that. So, assignment, please, in the plan book.
Chris, you're up here. We heard the most self-loaded guys things kind of.
Do you want to pass these out? I mean, I will, but if you want to keep doing things, you can.
Steve, do you want to pass this out? When you bow your head to go, I'll do it.
You just need to drop 3 at 3 different places.
I'll do it. I'm tired. Like, I have a pregnant mother and a 1-year-old sister.
Yeah.
That
You need to,
excuse got old, like,
you need to take a nap. Go talk with Miss Smith or Mr. Allen.
wait, you can have naps?
Well, they have couches.
That's dope. But yeah, Lauren, you can wait, during unscripted, like, my mom got pregnant. I found out that my mom was pregnant a month ago.
All right. We can dive in. So, angles and triangles. Now, a couple people actually were referencing some of our triangle laws when we were working on some of this stuff the other day, so I think we already know some of this.
Most of it.
Triangle angle sum theorem is obviously something you should already be aware of. So hopefully we all know that inside of a triangle we have 180 degrees total.
Wait, that's a theorem?
Triangle angle sum theorem. Theorem is fact. Theorem is known. We had this conversation. You're the one who said theorem is something known. Right? Theory is something
known.
known.
The triangle angle sum theorem. Like, I never learned that.
Not a triangle angle sum conjecture, which is something that we're not sure of, that we're still testing. Theorem we know. We can trust, right?
How did they test it? Did they give each triangle? Did they
Mathematicians try to disprove it.
4,000 different triangles?
Probably, yeah, but it would be like multiple mathematicians.
They give like bounties too.
Yeah, there's prizes. Like, and they literally just call them prizes.
Yeah,
for solving math problems or disproving math
I'll do
problems.
like famous math bounty hunters.
Anyone want to read?
The math mercenaries.
Thomas, will you hit us with that first paragraph?
Okay. Marcus decided to change.
So far.
Oh.
What?
So far in this chapter, you have investigated the angle pair relationships created when two lines intersect, forming vertical angles. You have also investigated the relationships created when a transversal intersects two parallel lines. Today, you will study the angle and side relationships that result when three non-parallel lines intersect, forming a triangle.
So, Marcos decided to change his tiling pattern by slicing those parallelograms into triangles. We want to use our resource page and color code to help our brains out, and just, who doesn't like coloring, all the angles that we can show are congruent. So, there should be some colored pencils around. There's a bin over there. There are packs sitting around. There's a pack right here. Use some colored pencils to notate all the congruent pairs. Then repeat that process for all three angles of the triangle.
You will have to do one triangle?
No, like in the triangle pattern. So extend it. So like if I red arc, I'm probably gonna zoom here.
Mr. Hudson,
Yo.
I need a new one. Okay, pretend.
Hey, I cut those fair and square and you're just gonna rip all my hard work. Yes.
Really? I don't know if this is mastery. You left a little chat.
I know, I'm scared of those things, like, very much. My borders are
That's the only extra, so don't mess that one up.
Okay,
So if we go bottom left of this triangle, then that'll also be here.
Everything is corresponding.
And then every corresponding set.
Inside interior, no shot.
That, even though it's outside, corresponding, corresponding.
I know. It's especially the waffle part.
All they're singing just sounds creepy. It's like American Horror Story.
It's very
And I want green eyes.
And I'm not tall at all.
I mean, like,
I'm not
Like,
old.
you're not tall.
You should end up with 3 different colors, essentially everywhere.
Really?
I made a circle rainbow.
That's what you should be making.
I couldn't make a circle angle because my drawing sucks.
Oh yeah, that's right.
Like, oh yes, that's right. I was coloring like a wrong thing for like half thing. I'm not. That's nice though. Create better lyrics. Ooh. You know his most famous song has these words in it. This is it.
Oh, you're a whole new group. You've never heard the quadratic formula song yet.
Because we need more terribly catchy
Oh,
songs.
it's probably even worse than Soy Esquapa or whatever that song title is.
And random Spanish teacher singing about
$10
Okay, if we can make it through this lesson, I'm showing you guys the quadratic formula song, and it's pretty awesome.
$10 is better.
It's drone footage and a guy singing on top of a mountain. So
What?
Yeah,
Never mind.
let's
It's
just. Dude, it's great. I'm not like cheesy building this up. It's great. It's a great video. It's just great.
But I got it. I mean, the lyrics and creativity for the Waffle song is just the way he says the anthem is amazing.
So every angle. Every angle here, and actually I can even do the exterior angles, right? So I make, this would also be red, this is also red.
The ones on that, those
Not
other
quarter
angles.
angles.
Are the same as the
Quarter
ones
angles.
on the-
No. I'm like, how do you make a triangle a square? You don't.
Right here. I was waiting for somebody to catch me, but if I make it black, will that make you happier?
Yes.
Yes!
Okay.
Why?
Because
it's a different
Thank
angle.
you.
Special rainbow!
It's not a different angle value.
It's the addition of the 2 angles instead of just one.
Yeah.
Wait till we all
This
come together.
one goes there.
Yeah.
Oh, it's special. It's special. It's a special one. It's special.
So by my drawing, what 2 angles would I need to put together to get that outside angle?
How much? Green and red. Christmas.
Or green and red or the blue. You do supplementary.
Green and red are the blue.
No,
Like they're-
or.
Blue is it black?
This could be blue.
No, like you do supplementary angles to find out, like you find a measure of blue. And
Oh, okay. Yeah. But this is equal. Like
Oh,
it's
like-
equal to red and green put together, right?
Which makes brown.
So wait a minute. If I look at just one triangle, right? Let's look at.
They look like scissors.
Forget everything else.
That's the same one.
Look at this triangle.
Yeah.
Right, we have green, red, blue.
Yeah.
And if I think about that, actually, let's make our life easier. Send that up there. Forget everything else except for this blue,
Wait.
this red, this green. Now, Jacob, you sounded like you had some information that you needed to share.
About,
This angle that I had made black, but now purple because purple's a fun color.
isn't that like an exterior angle or whatever it's called? And then the others are like remote interior or something like that?
I said that.
Remote angles?
So here's where we need to write stuff down because this is a theorem that we have. The exterior angle, not angel. Come on, brain, get with it today.
Exterior
Angel.
is made of feathers.
Just don't blink.
Just feathers.
All that matters is just don't blink. The exterior angle will equal the sum of, and Jacob even used all the fancy words, the remote interiors, which means the inside angle's not adjacent to the exterior. Now this only works if your exterior is a continuation of the side of the triangle and is not split by anything else. So this, if we continued this line up out, that would split the red and the green angles apart from each other. But if we don't continue that line and we have this as one large angle, it sums to red and green because, as a couple people stated, well, if blue, red, green make 180 and blue, purple are supplementary, then by substitution, purple is red, green. Because red, green, blue are supplementary and blue, purple are supplementary.
Should have used brown.
Yeah. Actually, that's just
I don't want to ask why. I'm afraid to ask why. So, back here. Yeah, that's not, trust me, what I was thinking.
What?
Making
Are you ready,
noises.
guys? Dude, look at this.
You guys actually want to know.
Yeah, let's, because students often actually struggle with this, look at part A of 105. We're going to go ahead and skip down to here. But we have a triangle given to us with legs 6 and 8, and we don't know if it's right or what it is. Talk with your team, make sure you all agree, and be particular, because there's some very tricky parts of setting this up. What's the potential length of the third side? So we just want to review this. It should be reviewed. If we don't remember it, that's okay. We'll get it back together. But what's the potential length of the third? No, we don't know. We don't know anything aside from legs are 6 and 8. So even how that looks, we can't even trust how it looks.
We know one fact for sure.
We know one thing. 2 legs are measures of 6 and 8.
And one more.
What?
The third side has to be less than 14. I mean, greater than 14.
Well,
Not greater.
that's the extension of what we're saying.
Yeah, it's not greater, it'd be less.
I'm not something.
If it was greater, you could have made it a triangle, be like this.
Yeah, it's called imagination. This is not a triangle. It's called imagination.
All we know is that the other side has to be greater. Imagination.
That statement was not true.
I said greater too!
I heard
Your
it.
imagination screwed up.
Greater than 8, but less than 8. Less than 14.
Yes.
Yeah, I said less than 14.
Not true.
Or greater.
It can't be greater.
Bless you. We done now?
Yes. Ian was
Steven,
Yeah.
you just drew attention. How do I know the minimum length that the third side could be? Minimum. Steven, what do I do with the other 2?
I don't know. You all have to add up or
So I have 2 sides here, right? Let's make this 8. And we'll make this 6. And we'll make that. I don't know,
Wait,
something
it's 7. Oh no.
small. Move.
Come on, you can do it.
I really don't think I can.
Yeah,
You can do
Yeah,
it.
the angles are too far apart.
If you can stretch it to be 2, then you can do it.
Why is it this is
Stop. What did I just click?
It's not.
I clicked something. Sorry. I should know better than to do this from the smartboard. Oh no, now it's angry.
Denied.
No.
Caution, this video may corrupt your computer.
Okay,
No.
Mr. Hunt, I think this wants a long time. It doesn't want to be voluntary.
Yeah, I think you
Give it some space.
There we go.
No, it doesn't have enough sleep. I think it's only depression.
So, all right, you guys said 2 will work.
You made the prize. Yeah, 2 will work.
That's not it.
That's a pretty triangle.
Yeah, no.
It has to be greater than 2.
Ah.
2.00.
So make it greater than 2.
C has to be greater than or greater than A minus B.
What the heck? Oh. Okay.
Can this work now?
Yes.
It can. Now, this model is kind of funky, so it won't line up quite right. But I can make a triangle now.
That's
What's
not
the
fine.
maximum this could be?
14.
Well,
So,
Less than 14.
2 does not work. Okay, the difference between your sides is the bottom restrictor, but it doesn't work.
When you add them.
So not equal. Right? Difference. Right? Subtract them. Then, as Nathan's saying, the maximum, but it doesn't work. 14. So when you guys said the maximum length was 14, that's a lie. The maximum length is 13.9999999.
So 14.
But
So
no.
14.
No.
But you said that it's a trick.
No. And
Wait,
you know what?
doesn't it have the equal to
No, no, Mr. Hall said that if it's 9 and I repeating.
He never said repeat.
I didn't say it goes on forever. I just said it's 9999999999999.
No,
Less than 14.
Yeah, it doesn't have the
It
equal
works.
to symbol.
There, then it'll be even closer.
It doesn't have the equal to symbol. Then
It'll
you
never
write
be close.
14.
Doesn't have an equal to. So we can write 14. I agree with you. But we can't use 14 as a side
You
note.
can't put that bottom line.
Okay? We cannot use
You
14
cannot use
as
a
a side
subtraction
note.
symbol.
Don't you get infinitely close?
Not really infinitely, because then you make the argument that infinitely close is
It's actually
there.
there.
All right. Which sets of these do work or don't work? Go through it and decide together. Agree.
One doesn't work. 2 would work. 3 would work. No. 3 would work. 4 would work. Yeah, 2 would work. No.
Anyone have a strategy for this test?
4 would and 2 and 3 would. Is that
We
right?
have a strategy for our test. We're gonna test this, right? You're looking at it, testing it like in your head. What should I be doing? How do I? So I heard somebody say 1 doesn't work, and more so I heard Satya. Why? What'd you do to determine 1 doesn't work?
Good answer. That one.
8 is less than 10 and 8 equals 5 plus 3.
Did you have a reason for choosing those numbers? Or you just those were the first 2 you saw.
Those 2 is all.
And then
Because those two 5 centimeters, 3 centimeters are the shortest sides.
Yeah, those are
easiest way to do this is grab your shortest sides and check. Do they sum to a length more than my third?
which they have to.
Nope, doesn't work. Right? Shortest sides here
It works.
make 13. It works. Steven?
So does it have to be more or can it be equal?
Cannot be
Cannot
equal because then it's a line.
Yeah.
Right, so that's what we looked at when we made
Oh,
the side
yeah.
2. It made a line. And then if we would have explored the 14, it would have made another line because they equal. There's no difference. So here, 2 short sides, 2, 4. Does it work?
Yes.
Yep.
No.
3, 5, 8.
No.
Nope. This would be a line. Let's check this conjecture. I'm trying to give you guys time to work on your homework because I know I've kind of stacked it on this week.
Do you prefer Crayola colored pencils over other colored pencils? What's the
I
difference?
don't really have a preference.
Well, it says that they're preferred by teachers.
Okay, let's write out the formal what we just said, just because we should. Yeah, spirit wear.
Wait, what?
Spirit wear.
Wait,
For-
Phoenix?
For our union, actually. That was not the Phoenix Spirit Wear shop.
Dragon one.
So don't trust the size we're about to draw. Okay, this is just a general drawing. But if you have triangle, ABC.
96, 4, and 1,000.
No. We don't know what they are. What we just said was A and B have to be bigger than C. Likewise, B and C have to be bigger than A, and A and C have to be bigger than B.
So
If you want to check a triangle all three ways around, that's what you got to make sure of. But then one that normally falls apart is your two small sides compared to your big side, not greater than. Sorry, go ahead.
I said an equilateral triangle wouldn't work, but that was really dumb. Because I thought 4 is not greater than 4, but then I realized that you had 2
8
4s.
is greater than 4.
I was dumb.
Grab something to draw on, whether it's notes or whatever it is.
Okay.
We get on the back of this. What is
I mean, you want to be able to clip it in your binder. So, I mean, if you hole punch that, I guess, okay. Hole puncher right here. Sorry, I have a cup of water and pond and stuff up here. I forgot my water bottle today. It is Maxwell's house.
What's Maxwell's house?
There's a coffee brand as Maxwell House. But I'm always like, so this comes from Maxwell.
the only coffee I'll ever like is no. This comes from what? Called Maxwell.
I only like Starbucks for a chocolate milkshake. But everyone calls them frappuccinos, but I'm there because I call them chocolate slushies.
Alright, I maybe lied. You might not need out something different. We might just talk through all these. So that we can just write out the practice work. So, there's a conjecture. And actually, sometimes the conjectures given to you in our class are already theorems, but right now for us, we just operate as a conjecture. Anyone remember the hinge theorem?
Yeah.
What did the hinge theorem tell us? Satya?
I don't exactly remember it, but I believe that you should be able to bend like one side. Not this. Like a hinge, like a door, you should be able to bend.
Right.
door,
I mean,
but
like
I don't-
it's named after a hinge. I agree.
Yeah, Jacob knows it better.
Jacob!
Okay, so the side opposites of the angle, the bigger you make the angle, the bigger the side is going to be.
Pretty concise way to say it. Anything else happen? Any other caveats in the hinge theorem?
The other two sides stay the same.
If those other two sides stay a fixed length. So your doorway and your door, even though they don't have to be the same size, they're fixed lengths. As the door opens wider, the distance between the edge of the door and the edge of the door frame increases. This should make sense. Right? In our brains, that should be like a what-dur. So, as we look at a triangle, if we have two angles that are similar to each other, not similar as in geometrically similar, but close, we know that the shortest side will be opposite the shortest angle. The medium side will be opposite the medium angle, and the longest side will be opposite the largest angle. So, when we're trying to figure out unknowns, this can help us in determining what range the side might fall in. So, if we didn't know the 9, we would know that it's the longest side because it's opposite the biggest angle.
Yep.
And the longest side has to be what compared to the shorter sides? Now be careful about how that question is asked. The longest side has to be what compared to the shorter? Thomas. Less than. Right? If we take the two smallers and put them together, now depending on what you mean, if you mean longer than any one of them, yes. It's got to be longer than 4, longer than 6. But it has to be less than the sum.
Oh yeah, because this is 10, it would go above.
So what we would know here is, let's say we didn't have not B, 9. Got to be bigger than 4, okay. But then when it has to be bigger than 6, forget the 4, just use the 6. So we know this will be greater than 6, but then it has to be less than 10. We have our range. So if we say that that other side is Z, 6 less than 10.
That's what I was
Wait.
doing previously
So
when
it
I
could
said,
be 6 points.
because I assumed that the
Yeah.
angles were larger and that was the largest.
Yeah. Now the problem is, be careful with
Yeah,
the
because
general
it's
triangles. Yeah. When it's like, oh, this doesn't actually look like this. It's just here for now. I still have a pen over here.
Can you count past
Yes, you can.
Infinity.
No, it's all the sauce.
Yes.
We're good on all this.
What's infinity squared?
Now this just gets a little weird, so I want to show you the trick. If we have a triangle ABC, like I'm looking at D, and we have lengths AB10, BC10, and AC12, how can we quickly know which angle is the biggest? Like obviously we know the rule, it's going to be opposite the biggest side, da-da-da. But how to, like, when we just look at it written out and we don't see the triangle, there's a way that we can, like, jump real quick to it. Hunter? It's the letter that's not included in the side name. Because it's a triangle, right? There are only 3 points. AC must be opposite to the angle that is not on that line. Right? So if we know AC is the biggest, angle B must be the biggest because it's not in the name of this side. Make sense? Let's check out 107, and I think that will be it for our lesson. You guys can work on homework for like 10 or 15. Okay. This.
107? Duh, we do have enough information. Yes, it is.
So I was actually going to breeze over this to 108. I said the wrong number. Why are we able to say that when given a right triangle, even if we don't know this and don't trust my drawing, and we don't know that, but Julie says that this is longest no matter what.
Well, yeah, the
How do we know this? Richner?
Because we know angle measure is 90, right?
Okay.
And because that is more than half, that is one half, 180, we know that each of the other two angles must be less than 90.
We don't know what they are, but we know they're less than 90 because they sum to 90.
So therefore 90 is the largest angle, and because it is opposite from EF, EF is the longest.
This is more support to why the hypotenuse always must be the longest side in a right triangle.
Not really.
Beyond right triangle rules, beyond the Pythagoras, for any triangle rules, utilizing Houston, or there's multiple theorems, this is why your hypotenuse has to be longest. Even if this is 89 and this is 1, still 90 is bigger.
Isn't the hypotenuse the long side of a triangle because the definition of a hypotenuse is the long side of a triangle?
That's not the definition of hypotenuse. The definition of hypotenuse is technically under the right angle. Hypo meaning under
What if it
or
has no
below.
angle?
It has no hypotenuse. Hypotenuse only exists in a right triangle. No.
I didn't know this.
Hey, why I'm employed, right? If you knew everything, I'd lose my job, man. All right, 108, check it.
You'll be hired for a long
Determine the minimum and maximum. So don't trust the drawing, only trust the numbers. So essentially make the double inequality. So here we'll say blank less than df less than blank. Right. Ooh, C gets interesting.
Wait, what? How do you?
What sorcery is this?
What have you done, Satya? Are you a failure?
No, look at C.
Oh, you can still do it.
But you don't look at.
You can't really tell which one is
Use the
larger.
variables.
Whatever, man.
Oh, but I thought you wanted to find the exact number.
Use the variable for A and B.
No, it would just be like BA
Yeah.
or B plus A minus 1.
Yeah, it's like writing the
We're
equation.
doing 19
Wait, B plus A minus 1?
plus.
No, it would just
Yeah.
be.
For the one on the right.
Okay, Steven, help me out. What's my minimum length here, but it doesn't actually work? Like, what's my restrictor?
Your minimum 12.
So I'm glad we're going over this. Do not trust the drawing. ED could be coming this way. All we know is that's 19, that's 13. We do not actually know how the triangle is built. The minimum length this could be, but it doesn't work, but we use it as a restrictor. 6. The difference between the sides.
Oh, so 19 could be like the
19 could be the biggest side. We're not saying that DF for sure has to be the biggest side. We're just saying DF's unknown. So then, if DF was the biggest side, what's the maximum like restrictor? It doesn't work for a side length. The sum, right? 32. So Steven, I'm going to pick on you again. Here. Because this should get a whole lot easier. 1 here.
29.
So then, Satya, since you were complaining about the sorcery or witchcraft or whatever
No,
you
I
called
know.
it,
That was valid.
here,
That would just be A minus B. Or B minus A.
Absolute value.
we don't know what's bigger. So the absolute value, and you can do B minus A or A minus B, it doesn't matter. Order doesn't matter because we made the absolute value. Then here, I can just add them. No absolute value needed. Be careful. This is something like what we might put on a test that would trip you up if you just put B minus A or A minus B, making the assumption. Do not make assumptions in that. It is oh so dangerous. Questions. Do your homework. You got 11 minutes.
Oh, I'm just gonna get it started. I just don't think I'll be able to do homework in this time.
You will. If you decide that you want to get something done, you will.
No, in 11 minutes.
11 minutes is a long